Hello class, welcome to this video on Module 3 Part 1 assessment. So we're going to go over one version of the Chapter 3 Part 1 test. So here, let's go ahead and get started. So for number 1, it says given AB is congruent to CD, prove that AC is congruent to BD. And so you got a word bank here. So here AB is congruent to CD, that's a given. And then it says, okay, so we're going from remember, when you see this, you're going from this congruent symbol to the equal symbol, right? When you see that, that's going to be definition of congruence. Anytime you go from the squiggly to the equals or from the equals to the squiggly, it's going to be definition of congruence. So here we have definition of congruence. Okay, so that takes care of that. And then we got AB plus BC equals BC plus CD. So we got AB plus BC equals CD. That is the segment addition postulate. You're taking two segments and you're combining them, you're adding them together to make a bigger segment, in this case AC, right? So that's called segment addition. So we got segment addition postulate for D. AB plus BC equals AC. And then we got BC plus CD equals BD. BC plus CD equals BD. So we're going to put segment addition for this one. Segment addition postulate. Okay, now for this one, now for C. Now, how do we get from B to C? Well, the way we get from B to C is we take B and we add BC to both sides. So notice that we're doing plus BC plus BC. We're adding the same thing to both sides. When you add the same quantity or the same number to both sides, that's referred to as addition property, right? So we have addition property of equality for that one. Okay, so it takes care of that one. And then for E, we have AC equals BD. Okay, so for this one, what we see is that, okay, well, we got AB plus BC, and that's equal to, what we can say is we can replace this, right, with AC. And so we can replace that with AC in this equation. And then we can replace this, BC and CD, we can replace it with BD. And so what we do is we end up getting BD equals AC. So when you replace something with another, we can refer to that as substitution. So we got substitution property. All right, so that takes care of number 1. And then remember, we're going from equals to the squiggly, so that's why we use definition of congruence right there. Okay, so number 2, it says Lupita is building a gate following this diagram. If the measure of angle LMN is equal to 43 degrees and the angle LMN is congruent to angle OMP, what is the measure of angle NMP? So we can say, okay, so LMN, that's this LMN, this angle right here, that's 43 degrees, right? So this is 43 degrees. And they said that LMN is congruent to OMP. So that means that this is 43 degrees as well. And then, so now they want to figure out, okay, what is NMP? So what is this red angle, right? So how do I get that red angle? Well, we know that these angles together add up to 180 degrees, right? So we can call this X, if you will, I guess. We can call that X. And so this adds up to 180. So because of that, we can set up an equation like this. That plus X equals 180. We got here 86 degrees plus X equals 180. Then we can subtract 86 on both sides. So we get X equals 70, or no, we got 94 degrees. Okay, so we got 94 degrees for NMP. All right, that's all you need to do for that one. All right, so number 3, point C is the midpoint of AB, and point B is between points A and D. So we got a line segment, AB, and we got point C is in the middle. It says the midpoints, that means that it's congruent on both sides there. And then it says point B is between A and D. So, there's a point D somewhere there. And it says if AD is 15 and BD is 7, so from there to there. What is CD? Well, that means that from here to here has to be 8 because 15 take away 7 is 8, right? And then if C is in the middle, then that means that from here to here is 4, right? Because half of 8. So then this is 4 on either side. And then we want to find CD, right? So if we want to get CD, which is from here to here, well, this is going to be 4 plus 7, right? And so it's got to be 11. So CD has to be 11. Okay, so just showing our work there with the picture and everything. All right, so we got number 4. It says if line segment EF is perpendicular, this is a symbol for perpendicular, to line segment FH, then the measure of angle EFG is equal to x plus 8 degrees, and the measure of angle GFH is equal to 7x plus 2 degrees. What is the measure of angle EF? G. So it says that it's perpendicular, so that means it crosses at a 90-degree angle. So that means this angle right here is 90 degrees, right? So let me just mark that as a 90-degree angle. And they said that EFG is x plus 8 and GFH is 7x plus 2. All right, so that means these two angles must add up to 100 or 90 degrees, right? So we're gonna add these up, and they should add up to 90 degrees. Right angle. All right, so now we can combine our like terms here and here. So we got 1x plus 7x is 8x. We got 8 plus 2 is 10. Now we can subtract 10 on both sides. We get 8x equals 80. So we can divide by 8 on both sides. So x equals 10. All right, and then we got to remember we're looking for angle EFG. So angle EFG is this angle right here. So we got to plug that into there. Okay, so the measure of angle EFG equals x plus 8. So we got to plug it in. So we're going to plug in 10 plus 8 is 18 degrees. Okay, so there's our final answer. All right, so that's number 4. Let's look at number 5. If RS is equal to 12, RT is 5, ST is 7, and RS and T are collinear, what is the relationship between points R, S, and T? Okay, so here it says RS is 12. So let's look at this here. It says RS and T are collinear, so that means they're on the same line. Now, we don't know where they are, but we do know that we can find out. So it says RS is 12 and RT is 5. That means T has to be closer to R than it is to S, right? So then if this is 5, then this is 7, and then the whole thing is 12, right? So that makes sense. So it says point T is between R and S. So yeah, that makes sense. Point T is between R and S. That's how we can tell. All right, so on number 6, if two lines intersect, then the lines are coplanar. And then identify the following statements as contrapositive, converse, or inverse. All right, so if two lines, so we got to see which one's the contrapositive. So the inverse or the converse is when you switch the P and the Q, so it's going to be Q goes to P. The original is P goes to Q, where P is the two lines intersect, and Q is the lines are coplanar, right? So that's P and goes to Q, and so the converse is you switch those. The inverse is when you negate them, so not P goes to not Q. And then the contrapositive is when you do both. So it's going to be not Q implies not P. So you switch them and you negate. So so number 6A, we have if two lines do not intersect, that sounds like not P. Not coplanar, that sounds like not Q. So it looks like this is an inverse. So we got C for inverse. It says if the two lines are coplanar, that sounds like Q. Then the lines intersect. So that sounds like P. So that's a converse. And then if two lines are not coplanar, so not Q, then they do not intersect. That's the contrapositive. All right, so that's number 6. Let's look at number 7. If possible, write the definition as a biconditional statement. So it says a square is a rectangle with 4 congruent sides. So biconditional looks like this. It's a two-sided arrow, right? It's a two-way street. Remember that has to be true if you have this is true and that's true. So you go both ways, right? Remember the symbol for and is the upside down V, so I'm going to use that. So both of those have to be true in order for the biconditional to be true. So let's see if that's the case here, if possible. A square is a rectangle, so this is going to be P if with 4 congruent sides. Actually, let's write this as an if-then statement. So we can say is, so we can write, so if a rectangle is a square, then it has 4 congruent sides. Let me just use the symbol for congruent. So this is the conditional. This is P implies Q, the forward direction. So if it's a rectangle, then it has 4 congruent sides. Is that true? Well, if it's a square, then it has 4 congruent sides. That's true. Now we're going to reverse it, right? Q implies P. So if a rectangle has 4 congruent sides, then it's a square. Is that true? The answer is yes, it's true. So it's true in both directions. So therefore, we can write a biconditional. And we can say a rectangle is a square if and only if. That's another way of saying if and only if. It has 4 congruent sides. Okay, so here we go. So it's got to be C. Now, if one of these were false, then it would be D. It cannot be written as biconditional. But since both of these are true, we can write it as biconditional. Okay, so let's look at number 8. Given x, y, and z, w intersect at point A, which conjecture is always true about the given statement? It says, so x, y, and z, w intersect at point A. So let's look at XA is equal to AY. Is that true? Does XA have to be equal to AY? Remember, it has to always be true. All we know is that these two lines intersect at point A. So we got A here, and we know that they intersect. Right? But do they have to intersect? Do they have to intersect so that it's equal to on both sides? Well, in this example, it looks like it's equal, but it doesn't have to intersect like, where it's the same on both sides. It could intersect somewhere different, right? So we could have A here, we could have X there, we could have Y there. And in that case, maybe this is ZW or something like that. Here in this case, XA does not equal to AY, right? So it's not necessarily true. So it can't be this. Angle XAZ is acute. In this example, it's not acute, it's obtuse, right? This is an example. It doesn't have to be a right angle or an acute angle. It could be obtuse or whatever. So it can't be that one. XY is perpendicular. XY is perpendicular means it crosses at 90 degrees. Is that necessarily true? Well, no. In this picture, it's not true that it's a 90-degree angle. So it cannot be C either. X, Y, Z, and W are non-collinear. X, Y, Z, and W, yes, they're non-collinear. They're not on the same line. So this has got to be true. This is always true for this statement. All right, so number 9, what is a counterexample for the conjecture? Counterexample is something that refutes it, that goes against it, right? Proves it false. So if the perimeter of a rectangle is 40 units, then the area must be at least 1 square unit. Perimeter is when you add up all the sides, right? So so if you were to add up all the sides, you would get 40. But if you multiply base times height or length times width, you would get 1. Okay, so that's what we're looking for. So let's look at an example where this is true, but this is false. That's what we're looking for, okay? We want this to be true, but this to be false for a counterexample. All right, so a square with a side length of 10 has a perimeter of 40. So yeah, 10, 10, 10, 10, right? That's 40. And an area of 100. Yeah, because 10 times 10 is 100, right? Which is not equal to 1. So that looks pretty good so far. So that looks pretty good. However, they wanted it to be a rectangle. So even though a square is a rectangle, we technically want this to just be any rectangle. It doesn't have to be a square, right? So let's do an example where we have a rectangle that's not a square, right? So so we want this to be a rectangle. So let's do that. So because of that, we're not going to choose A just yet. We're going to look to see a rectangle. That looks good so far, with a length of 19.99 and a width of 0.01. So if I add this plus this and then 19.99 and 0.01, that would get me to 40. So that's true. And then it says an area of 0.1999. That's true. If I multiply these two numbers, I get an area of 0.1999. So yeah, that's actually true. This is what we're looking for. It's not equal to 1, but the perimeter is 40. So this has got to be the answer. Now, if you look at the next one, it says the length is 15 and the width is 5. So let's check to see why that one's not true. So guys, because if that's 15, then it's going to be 15, 15, 5, and 5. So this gives me a perimeter of 40. If I add up these 4, I get 40. However, if I multiply 15 times 5, that gives me an area of 75, but 75 is at least 1, right? At least 1 means greater than or equal to 1. So that means this is false because 75 is bigger than 1. All right, so that's why you can't choose that. All right, so let's finish up here with number 10, and we got maybe a couple, a few more. So statements 1 and 2 are true conditional statements. Statement 1, if a figure is a square, then it is a rectangle. Statement 2, if a figure is a rectangle, then it is a parallelogram. Which conclusion is valid? So here it says we got statement P, a figure is a square. Statement Q, a figure is a rectangle. Statement Q, a figure is a rectangle. It's the same statement, right? So I leave it with the same letter Q. And then the figure is a parallelogram. That's a different statement, so I'm going to use statement R, P, Q, and R. So now we got for statement 1, if P implies Q, statement 2, Q implies R. Well, here we go. So if P implies Q and Q implies R, well, that means that P must imply R, right? That means we can assume that P implies R. So in other words, we can get rid of this middleman and just go from P to R. All right, so this is called the law of syllogism. So which conclusion is valid? And P goes to R. So that means if it's a square, then it has to be a parallelogram, right? So if figure is a square, then figure A is parallelogram. All right, so number 10 is A. 11, if two lines have the same slope, then they are parallel. Lines M and N have a slope of 2. So okay, so we have P goes to Q, so P implies Q. If they have the same slope, then they're parallel. Now they said that M and N have a slope of 2, so they're saying that P is true. that they have a slope of 2. Well, then if they have a slope of 2, that means that they must be parallel, right? We can conclude that the lines are parallel. And that's called the law of detachment. Now, if they said that the lines are parallel, right, then we can't necessarily say that they have, like if this were a biconditional, we can go backwards, but technically speaking, we can't apply the law of detachment in this example and go backwards. Even though it would be a biconditional, it should be a biconditional where you can go both ways. In this example specifically, the law of detachment, you can't use law of detachment if by going backwards, right? Number 12, find the volume of the figure below. So this is a triangular prism. Why is it a prism? Because you have two of the same base here, and here in this case the front and the back. So the base is a triangle, right? Just shaded there, and the height of the triangle is 5, and then the base of the triangle is 12 in it, so we can multiply, and they're at a right angle. Remember, the area of a triangle is 1/2 base times height. Okay, so we're going to use if you go to your formula sheet, the area or the volume of a prism is capital B, the area of the base, times the height or the depth of the prism. In this case, the B, capital B, is the area of a triangle, which is 1/2 base times height, so 12 times 5. That's your B. And then your height is that third dimension, right? This depth here, which is going to be 10 from here to here, right? Because it gives it that third dimension. So it's going to be 10. So multiply that by 10, you get your answer. So we got 1/2 of 12 is 6. 6 times 5 is 30, and 30 times 10 is 300. Remember, the units of volume are units cubed. So we got 300 centimeters cubed. Okay. All right, so we're in the last problem, number 13. In the figure, CD and CB are opposite rays, and CA bisects. Bisects means that it cuts in half, right? So it's going to cut this angle in half. So if BCE is getting cut in half, that means that these two little angles are the same. Okay, and then they said that CD and CB are opposite rays. Okay, now it says ECA, so that's this angle here in the middle, is 14x minus 2. And they said ACB is 12x plus 8. Well, we established that they're equal, so because of the bisection that's going on, right? The bisector. So therefore, we're going to set those two equal. All right, and there's my equation, so I can solve it. I'm going to move the 12x to the other side, subtract 12x on both sides. And I'm going to add 2 to both sides, move the constant to the left side. I'm going to use division property, divide by 2. I get x equals 5. Then remember to answer the question. It says angle ECA. And the angle ECA is, it says here it's 14x minus 2. So let's plug that in. We got 14 times 5 minus 2. So we got 14 times 5. That's going to give you 70. Take away 2. So that's 68 degrees. All right, guys, that's going to do it for the video. Hope you found this useful and informative. And as usual, I'll see you in the next one.